Today we're going to be talking about physical properties of metals, and then we're going to move into talking about making salts through neutralization reactions. Here we go. Also, first off, to remember, matter is anything that has mass and takes up space, but is not energy. So properties, how elements look and react. So we're going to be talking about the properties of metals today. And we have 6 physical properties of metals. The first one I want you to remember is how they look. So metals can be shiny or dull. If you take a look at the picture on the left, you see a pile of pennies, and they are all tarnished. They've gone through a chemical reaction with oxygen called an oxidation reaction, creating the tarnish, the dark color on the surface, and that is dull. The metal, you can clean the metal and make it shiny again. It's very easy to do. A common way to do that is putting the metal in a solution of salt and vinegar. Picture on the left shows an old Volkswagen Beetle that's made out of iron. Iron, when it's exposed to oxygen, either water or oxygen in the air, will go through the same type of reaction, oxidation reaction, creating iron oxide, which is the red rust as a product that you see in this picture on the Volkswagen Beetle. Second property of metals, high conductivity, which is the ability to transfer heat or electricity to another object. We all know this. You touch the spoon in the pot, in the soup pot, and you will get burned. Also know that wires are made out of metal, aluminium, because it's a good conductor of electricity. So this is a review. I hope we all know this. Solid, liquid, and gas are the 3 types of matter. And I want to refresh your memory that it's heat that makes matter change states. Our melting point is the temperature at which a solid turns to a liquid. Boiling point is the temperature at which a liquid turns to a gas. And you learned this in M3EP. This is a review for you, but if you need to pause the video and write this down again, please do. Energy in or energy out. Changing states of matter. Okay, so here's a graph. Last year we did a lab where we took ice and we put it on a Bunsen burner. Energy went in as a form of heat. And so the ice changed state from a solid to a liquid at 0 degrees. This was melting, its melting point. All the temperature stayed the same throughout that entire time when the ice was changing state. And then once all the ice had melted, the temperature of the water began to rise again, and it continued to rise until it got to 100 degrees Celsius, at which time the water began to boil, changing from a liquid into a gas. Now, if you can reverse this, it's physical changes, you can reverse it. If you were to take energy out by cooling, the gas would change to a liquid. We call that condensation. And again, at 0 degrees Celsius, the liquid would change to a solid, and we call this freezing. Third property we want you to remember, all metals are solid at room temperature except mercury. You can see all the metals on the left-hand side of the periodic table of elements. And there are some gases on the right-hand side. Well, all the gases are on the right-hand side, but you can see, all the nonmetals are on the right-hand side, but you can see that the ones in green are gas at room temperature. Malleable. Funny picture here. Malleable is a property of metals. They can be bent and hammered flat. Fifth physical property to remember is that the word is ductile. It means that metal can be pulled into wires. The sixth physical property to remember is magnetic or not. Magnetic means to be attracted to a magnet. And there are 3 metals that are magnetic, and these are iron, nickel, and cobalt. Okay, that's enough about physical properties. we're going to be moving into chemical reactions, the chemical properties of metals. So elements in the same group or column, which go up and down on the periodic table, react in similar ways. Both metals and nonmetals react with oxygen to make oxides. Okay, so when we have elements that combine into molecules, if a metal or a nonmetal combines with oxygen, it makes an oxide. Example 1, you have carbon and oxygen making carbon dioxide. Example 2 is magnesium and oxygen making magnesium oxide. Magnesium oxide is a compound, remembering that a compound is 2 or more different atoms that have joined together. All compounds, all molecules have a chemical formula, which we write as the example for magnesium oxide, MgO, the chemical name of the element. Okay, so in summary, metals. 1, how they look, shiny or dull. 2, high conductivity. 3, all metals are solid at room temperature except for mercury. 4, malleable. 5, ductile. And 6, magnetic. Remember the 3 metals that are magnetic. And just a refresher about nonmetals, to remember, nonmetals are the opposite of metals. They are not shiny. They are poor conductors. They're mostly gases at room temperature. And the solid nonmetals are brittle, which means they can break easily. Example here being sulfur. Alright, so we're going to move into making salts. This is actually E2 and not E1 in your book. So what is a salt? A salt is a substance formed in a neutralization reaction. So let's remember a couple things here. So what is the opposite of an acid? So the opposite of an acid is a base. And another thing to remember, what is an alkali? Many times we say the word base and alkali are synonyms, but actually an alkali is a base in solution, a base that dissolves in water. And a neutralization reaction is when an alkali, a base in solution, and an acid combine to make a salt and water. So another thing to remember, the pH scale. So very strong acids have a pH of 1. Very strong alkalis have a pH of 14. And a neutral solution has a pH of 7, which is also the pH of water. And this scale is used to measure the strength or weakness of acids and alkalis in solution. Alright, so here is a simple word equation for these chemical reactions of acids and alkalis. So on the left hand side you have your reactants, an acid plus an alkali, and that makes your products. On the right, the salt plus water. So some alkalis are metal hydroxides. There's a picture of sodium hydroxide on the right. Sodium hydroxide is a strong alkali. It's the most common metal hydroxide. And the products, the main product for sodium hydroxide is drain cleaner, sometimes called soda phi. Another strong alkali is potassium hydroxide, and a product for that is wood cleaner. And a few other examples, we have lithium hydroxide, copper hydroxide, aluminium hydroxide, and iron hydroxide. The hydroxide is the OH on the end of the name of the molecule. So here is another, there's your simple word equation for acids and alkalis, and here's a specific example, the most common example that we use in chemistry at the M3EP level. Sodium hydroxide plus hydrochloric acid make sodium chloride plus water. And then there's the atom ball diagram down at the bottom showing this. Very interesting to know that sodium is very explosive, very reactive, and chlorine is a poisonous gas. So those elements alone are very dangerous. But when you combine them and they go through this neutralization reaction, it becomes a new product, sodium chloride, which is very, very stable. The electrons hold on to each other so strongly that it's an extremely stable molecule. And sodium chloride is common table salt that we put on our food as an additive, a flavor additive. So if you leave the neutral solution to evaporate, you will see the salt crystals which can be used. So in the lab, picture on the left there, it shows a Bunsen burner on a stand, and there's a water bath or water that's boiling, which will cause the solution, in this case it's copper sulphate solution, to evaporate, leaving the solid behind, the solid salt. The water evaporates out, leaving the solid salt behind. Picture on the right shows commercial salt production on salt flats. Basic solar evaporation of the water, which leaves behind the salt, which can be collected, sold as a food additive. So naming the salt. This is the last thing that I'm going to ask you to remember. To name the salt, the first part is the name of the metal from the alkali. And the second part is from the acid. So hydrochloric acid makes chloride salts, sodium chloride, and NaCl. And sulfuric acid makes sulfate salts. Magnesium sulfate, MgSO4, is the example there. And nitric acid makes nitrate salts. And the example there is potassium nitrate, KNO3. So it's important that you remember hydrochloric acid makes chloride salts, sulfuric acid makes sulfate salts, and nitric acid makes nitrate salts. The picture on the bottom there, interestingly enough, is KNO3, potassium nitrate. And there's a commercial product on the right, potassium nitrate, which helps plants grow. It helps root growth, seed growth, and also fruit growth. All right, well, that's it for today. Please get all your notes copied. I'll be checking them in class. I'll see you then. Bye-bye.